Hey, AK again, welcome back. This is video number 4 in the series called 1 Hour Matlab. In this video, we are shifting gears up a little bit and we're going to look at the topic of curve fitting in Matlab. The need for curve fitting comes up many times in both life and physical sciences. Since we have been concentrating heavily on aerospace and rocketry in the previous videos, I thought we will look at a practical example from the biotechnology field in this video. Imagine you are a scientist developing a new drug against a dangerous strain of bacteria. You are testing the potency of your new drug upon a Petri dish full of bacteria colonies. You are measuring the quantity of bacteria that are alive against the drug concentration. The drug concentration is plotted along the x-axis. The bacteria quantity is measured in the units of CFU per plate, or colony forming units per plate. This is the raw data. This on the x-axis is the drug concentration measured in micrograms per milliliter, and on the y-axis is the colony forming units bacteria per plate. So looking at the raw data again, we have the data for 0, 5, 10, 15, 20, 25, 30 and 35. 0 is, by the way, the reference reference value, which is. But the question is, what if you want to find out the CFU, the bacteria quantity, for a drug concentration of 7 micrograms per milliliter? We don't have the data, all right? So we just have the data points for these individual drug concentrations. But another colleague of ours, might want to find, okay, if I set the drug concentration to 7 or 16 or 31, whatever, what will be the colony forming units per plate bacteria? And this is where the curve fitting actually comes in. And what we are looking for is to get a curve, which is the dotted T line here. And given this X and Y data, we want to mathematically find a curve that actually passes through, in other words, almost passes through these points and approximates this shape. Okay, that's actually curve fitting. This is a typical scenario. You have the raw data in actually yellow, and we want to know the bacteria quantity for a drug concentration of 7 micrograms per milliliter. Okay, we don't have the data, but if we have the mathematical equation for this curve, we can just go up like this. For this drug concentration, we can say this will be the bacteria quantity. So this, in essence, what curve fitting is all about. Okay, so again, what we need is to find a math equation for this dotted T line, and we need Matlab's help to do that. All right, there are multiple ways of doing curve fitting, and we can use different types of mathematical equations to do the curve fitting, to find this mathematical expression for this curve. Today I'm actually going to talk about a specific set of equations called polynomial equations. So a first degree polynomial it should be very familiar to you. This is nothing but a linear equation. Why the output is a0 plus a1x. a0 and a1 are called the polynomial coefficients, and the second degree polynomial equation should be a0 plus a1x plus a2x squared, and so on and so forth. And for the nth degree polynomial, the equation is a0 plus a1x, etc., up to an x to the power of n. So we will use a polynomial equation to do the curve fitting. And the problem at hand is, we know the y and the x data. We want to find these coefficients a0, a1, a2 up to an using Matlab. Okay, let's fire up Matlab. This is the x data and this is the y data, and you already know how this looks like when we plot it. This is the raw data, x and y. Let's put a breakpoint here and actually run it. Alright, this is the familiar plot that you've been looking at so far. Now, again, what we want to do is we want to find a polynomial equation for this shape in Matlab. Alright, the way to do that is using a command called polyfit. So what polyfit does is, it takes the x data and it takes the y data, and it's trying to fit a sixth order polynomial to this data. So this is the sixth degree polynomial whose coefficients we are trying to estimate using Matlab. Matlab actually takes in the x data and y data, and it will calculate A0, A1 up to A6. That's the problem at hand. And the command that we use for that one is polyfit. And the polyfit command takes the x data, the x vector, which is this one here, and it takes the y vector. And the third argument is the degree of the polynomial. Recall that the degree of the polynomial is, in this case, it is actually the degree is 6, which means we are looking at a polynomial that looks like this, a 6th degree polynomial. All right. Okay, let's run the polyfit command. Just executing just this line using step. So this is what Matlab has returned, and these are the coefficients of the polynomial. By the way, this is actually A6, A5, A4, A3, A2, A1, A0. The coefficients I'm talking about is this one. So Matlab actually returns them in the reverse order. A6 is actually returned first, A5 next, etc., and A0 last. So if we come back to Matlab, this is A6, this coefficient here, and this one is A0. All right, coming back to Matlab again. So we have this set of polynomial coefficients, right? So how do we use this to solve the problem at hand, which is we want to know the amount of bacteria for a drug concentration of 7 micrograms per milliliter. Recall that was the original question, right? That led to this polyfitting quest. So we know the x value, which is 7 micrograms per milliliter, and we just want to find out, okay, what will be the y value, and how do we use the polynomial coefficients that we just got from Matlab to solve this problem? It's pretty simple. We need to use another Matlab command called polyval, and the way to solve this problem is you input the new x value, which in this case is actually 7, and the first argument is, of course, the polynomial coefficients vector, p a6, a5, etc., up to a0, and the second command is the x value, and Matlab returns the y value using this polynomial equation. So let's just run this step, and the y new is 3.039. Let's actually do a format change. And 309.3909. Okay, so if we just go back to the plot here, what we're saying is for a drug concentration of 7 micrograms per milliliter, we will have approximately 309 CFU per plate. Okay, so this is how we use the polynomial coefficients that the Matlab actually given us. Okay, so now I'm going to do a different operation. I just want to see, using these polynomial coefficients, I just want to see how good is the fit, how good is the polynomial equation trying to approximate the raw data that we actually sent in. In order to do that, I'm going to create a new vector x1, which is set equal to the original x data, which is this one. And I mean, you don't have to do that, but I'm actually doing it for clarity of nomenclature. So this is the x vector, and I'm using again the polyval command. And notice this time, p is just the polynomial coefficients. Okay, notice this time the x value is not a single float. It's actually a vector of floats. Okay. In this case, it is the x data that comes in. It's a vector, and if you execute the polyval command, okay, the output of the polyval will be a vector. So let's execute that step, and y1. Okay, so we can actually plot this, which we're going to do in this set of commands. Just say continue. And this is what we get. So the yellow data is the original measured data, and the purple line is what we get using the polynomial equation using the polynomial coefficients that Matlab just gave us. As you notice, the fit is not 100% perfect. That's okay. We can keep increasing the order of the polynomial equation, and we can get closer and closer to the original data. This is a push and pull between how close you want the polynomial curve to be to approximate the data points against what is the complexity that you can live with when it comes to the mathematical equation. The more polynomial coefficients you have, the more complex the equation becomes. And at some point, you'll have to actually take a scientific or an engineering decision. Okay, I'm stopping here. For this specific problem, I found that a 6th degree polynomial is more than enough to do the job, and I'm just accepting a 6th degree polynomial. Okay, so this is how you do curve fitting in Matlab. And this technique, using a polynomial equation, polynomial curve fitting, I use it again and again in my professional life. And this is a very useful technique. I hope you also found this useful. And thank you very much for watching. I will see you in the next video.